Alright, so in this video, I'm going to solve the equation x to the power of 2 minus x to the power of 3 is equal to 80. So, to solve this equation, I'm going to first start by subtracting 80 on both sides. So now I get x to the power of 2 minus x to the power of 3 minus 80 is equal to 0. Now from here, I'm going to replace 80, negative 80, I should say, with negative 16 minus 64. Now, I'm going to rewrite this as, I'm going to first rewrite negative 16 as negative 4 squared, and negative 64 as negative 4 to the power of 3. And I'm going to group x squared with negative 4 squared, and x to the power of 3 with negative 4 to the power of 3. So now, there's two properties that I'm going to use. And before that, I'm going to rewrite this as x squared minus 4 squared, and I'm going to group this minus x to the power of 3 plus 4 to the power of 3. We put this plus because this negative sign distributes. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. And if I have something in the form a to the power of 3 plus b to the power of 3, which is this is equal to a plus b times a squared minus ab plus b squared. So for x squared minus 4 squared, it's going to turn into x plus 4 times x minus 4. I have this minus a to the power of 3 plus b to the power of 3, or in this case, x to the power of 3 plus 4 to the power of 3 is going to turn into x plus 4 times x squared minus 4x plus 16. Now, because both of these terms have x plus 4 in them, I can factor out x plus 4. So I get x plus 4 times x minus 4 minus x squared minus 4x plus 16 is equal to 0. Now from here, this is equal to x plus 4 times x minus 4 minus x squared plus 4x minus 16. I just distribute the negative sign is equal to 0. And let's simplify this even more. I get x plus 4 times negative x squared plus 5x minus 20 is equal to 0. So I get two equations from this. I get x plus 4 equals 0, and negative x squared plus 5x minus 20 is equal to 0. So first, for x plus 4 equals 0, all we have to do is subtract 4 on both sides, and we get x is equal to negative 4. Now, for negative x squared plus 5x minus 20 equals 0, well, first off, we have a negative sign in front of x squared, so I'm actually going to get rid of that by multiplying both sides by negative 1. So I get x squared minus 5x plus 20 is equal to 0. And now, to solve this, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 5, and c is 20. So I get x is equal to negative of negative 5 plus or minus the square root of b squared, which is negative 5 squared, which is 25, minus 4 times a, which is 1, times c, which is 20, all over 2a, so 2 times 1. And this is equal to 5 plus or minus the square root of 25 minus 80 over 2, which is equal to 5 plus or minus the square root of negative 55 over 2. Now, this is equal to the square root of 55 times the square root of negative 1 over 2. And the square root of negative 1 is equal to the imaginary number I. So I get 5 plus or minus the square root of 55i over 2. So this is two more solutions to this equation. Thank you for watching. Please make sure to subscribe, leave a like, and share this to any of your friends and family. Alright, so in this video, I'm going to be finding out which one is greater, 33 to the power of 44 or 44 to the power of 33. So we want to find out which one is the greater number. So what I'm first going to do is take the power of 1 over 11 on both sides. And the reason I'm doing this is so I can use the property a to the power of m to the power of n is equal to a to the power of m times n. So this turns into 33 to the power of 44 over 11, which is equal to 33 to the power of 4. And I also have 44 to the power of 33 over 11, which is equal to 44 to the power of 3. Now, I'm going to rewrite 33 to the power of 4 as 3 times 11 to the power of 4, and 44 to the power of 3 as 4 times 11 to the power of 3. So now I get 3 to the power of 4 times 11 to the power of 4, or 4 to the power of 3 times 11 to the power of 3. Now, 11 to the power of 4, I'm going to rewrite as 11 to the power of 3 plus 1. So now I get 3 to the power of 4 times 11 to the power of 3 times 11, because 11 to the power of 3 plus 1 is equal to 11 to the power of 3 times 11. Or I still have 4 to the power of 3 times 11 to the power of 3. And now we see that 11 to the power of 3 is present in both of these, so we can just cancel out because it's there for both terms. So I'm just comparing 3 to the power of 4 times 11, or 4 to the power of 3. Now 3 to the power of 4 is 81, so I have 81 times 11, or 4 to the power of 3, which is 64. Now 81 is already greater than 64, and on top of that, we're also multiplying by 11, which turns into 891, or 64, meaning 891 is greater, so 33 to the power of 44 is the greater term.